Semi, not really. Well, since it didn't go okay, we definitely need to finish this. And what we want to do is we want to sketch the transformed area. And we call the transformed area R, and this is S. So S is the pre-image, what we start with. R is the image, what we map into, what we transform into. Now to do this, we said we need to look at the original boundaries of our function, and that is we need to sketch S. S is in the UV plane. And we notice that S is a rectangle, right? It's this rectangle right here. Well, it's actually supposed to be a square. So we're going to pretend it's all a square-like. Now to find it, what we do is we just select one edge and we transform that single edge. And so last time we looked at the edge right there, right? That's the one we started with. That was right. And we said that happens when when b is equal to 0, right? And so what we did is we took b equals 0 and we plugged it in here. We got x equals u squared and y equals 0. And we said what this means is that when we map this line into the xy plane over here, it's going to be with y equal to 0. We need to figure out what x is, though, and to figure out what x is, we said we know that u is bounded between two values. We know u is between 0 and 1, right? And so if we take a number and we square it, what's the smallest x could be? 0, what's the largest x could be? 1, right? Because anything in between, if I square like 1/2, it's going to be between 0 and 1, right? So I run this from 0 out to 1. There's the line, once again, y equals 0. To find the other one, what did we plug in next? I can't remember. We did this in class. What was the next one we plugged in? U equals 1. So let's plug in u equals 1. When we plug in u equals 1, I come back over here. X equals 1 minus b squared. Y equals 2b. That was good. Now what I want to do is I want to get an equation with only my two variables for that plane. That is, I want only x's and y's. I have two different equations. So what I do is I use substitution. I'm going to look at this equation right here. I'm going to take it over and I'm going to write it as 1/2 y equals b. What did I do with it after that?
Sub it in.
I subbed it in, right? I substituted it in to my first one, which gave me x equals 1 minus 1/2 y squared, or x equals 1 minus 1/4 y squared. Good. Here we said this is what kind of shape?
Parabola.
Is it opening on the x or the y axis?
Y. No.
Opening on the x-axis, right? Because x equals y squared. Is it going to be opening to the left or to the right? Left, because it's negative, so it's going to point towards the negative x value. Now to figure out exactly where this parabola is, that is, where it's going to run, we need to look at the restrictions we have. Well, since we've plugged in for u, we need to look at the restrictions on v. So bringing this over here, we know that 0 is less than or equal to b, which is less than or equal to 1. If v is restricted between 0 and 1, what is y restricted in between?
0 and 2.
Well, let's see here. The biggest I could make y would be if I plugged in which one of these values?
0.
Biggest I can make it
1.
would be if I plugged in 1, right? So if I plugged 1 in here, I would get 2, right? And the smallest I could get would be if I plugged in 0. So y is running between 0 and 2. Are we okay with that? Are there any questions? That's enough with our y values. Let's think about our parabola now. Where is that parabola centered? It's got a shift, right? It's shifted what? 1, and we want to stay up, but because this is on the x-axis, it's shifted which direction? I think we're having a little bit of trouble visualizing this. I want to make sure we can, so I'm going to write it over here. If I want to maximize x, what value would I plug in for y?
0.
I need to plug in 0. Tell me why I want she told me what, I want someone else to tell me why. How do I know plugging in 0 will make this as big as possible? Because when I plug anything in, it's going to be subtracted off, right? The biggest I could make it would be if I subtract nothing off, which would be if y equals 0. So if y equals 0, I have x equals 1, right? That is the biggest value I can get, so that's where the vertex of this parabola is going to be. So I'm going to come out to 0, 1. And you guys told me my parabola is pointing left or right? Left. So all I have to do is figure out now where it's going to stop. I know y is bound between 0 and 2, right? So what I really need to do is figure out where is that parabola when y is 2. So I know once again it's bound by y equals 2, because that's my restriction for y. How can I figure out where it stops? I can plug in 2 for y up here, right? X equals 1 minus 1/4, 2 squared. 1 minus, say 1, or 0. What this means is my parabola stops where y is 2 and x is 0. So all I have to do now is go ahead and sketch it out. Question. Well, I've got another step to do, right? I've only done 1 and 2, two of the sides I have over here. Let's talk about the third one. This is kind of where we stopped last time. Third one. What's the third side I can look at? Here. Right now I traced this one, right? And then I came up this direction with u equals 1. What is that third side? Z equals 1, right? So I'm going to plug in Z equals 1 here, and when I do that, I'll get x equals u squared minus 1, and y equals 2, 0. That's good. I'm going to do exactly the same thing, right? I'm going to isolate 1/2 y equals u. I'm going to take that, I'm going to plug it in there. X equals 1/4 y squared minus 1. What am I going to do next? I know it's a parabola. What do I have to find? Am I going to get the entire parabola? No. So what do I need to find? I need to figure out where it is. How am I going to do that?
You're looking for the
I need to figure out where it's bound, right? Let's think about this here. I know I originally used u here, right? What is u bound between? 0 and 1? Which means I can figure out what y is bound between, right? I'm basically finding the domain of this function right here. So I need to find out what y is in between. This will be 0 and 2, right? I can't tell if you're bored or confused. Anyone want to give me some feedback? No, okay. Yep. And the reason why is because both of the y's got out. We'll get to that now. So here, we need to figure out it's a parabola. It's on the x-axis. What direction is it facing? Left or right? It's a positive, right? So it's facing to the right, facing towards positive x values. To figure out where it's going to start, I think about where it's maximized. What value of y would I plug in to maximize this? I plug in 2. I want to maximize it, right? If I'm taking something minus 1, this thing should be as big as possible to maximize it, right? So I'm going to plug in, you guys told me y equals 2, right? And so when y equals 2, x is equal to 0. So I'm point at 2, 0, or 0, 2, I should say. And what value would I plug in to minimize this? 0, right? Because 0 minus 1 can be as small as I can get. X equals -1. So I'm point at -1. 0 there, and all I'm gonna do is I'm gonna connect them now. I have 3 on my side, then I need to do one more, I need to do side 4. What am I going to use to find side 4? Then u equals 0, do we agree? Is this final side right here? Sure enough, it's u equals 0. So coming over here, u equals 0, I plug it in exactly like I would have done before. It's x equals negative b squared, right? And y equals, that's y equals here. Sure, right? So I plug in u equals 0 to my 2 original equations over there, and get y equals 0. What is this going to look like? Is this going to be another parabola-like thing? What's it going to be? Straight line, right? So the only thing I have to do is figure out where the x values are going to lay. To do that, let's look at what b is in between. B is between 0 and 1, right? What value of b would I plug in to maximize the x value? Think about it before you say anything. What value of b would I plug in to maximize it? 0, right? What one would I plug in to minimize? 1. Which means that from this situation here, I get that x is going to be bound between 0, right? And what will be the lowest value for x? Negative 1, right? Which tells me my final side lies on y equals 0 and negative 1 to positive 1. It's not a basic number, it's a negative. Yep. Question. This is R, and this is X. What we did is we used the transformation T, given these two, to take our points in S over the points in R. What would I need to go back?
1 to 1.
Our transformation has to be 1 to 1, right? I want you to look at this. Is this going to be 1 to 1? This transformation right here. Do you think it's 1 to 1? 1 to 1 means that each point in UV would go to a unique point in XY. Can you think of a value for U and V, two coordinates that would give us the same X and Y? Okay, I just plug in 1, 0, right? That would give me X equals, I plugged in 1, 0. What would X be? 1, right? What would Y be? Here's 0. Do we agree? Can you think of another UV point that would give me the same X and Y? And negative 1, 0. Would that give me the same X, Y? Is our transformation 1 to 1? No, right? Which means this idea of going back using a T inverse isn't going to work. But that's what we would like to take us back. Questions on how we did the transformation? No? Quiet today. I'm nervous. Okay, I'm going to go ahead and erase this. The whole point of transformations is that we've already done them and they've been really useful for integration. The transformations we've done so far have taken us from rectangular coordinates to polar, rectangular to spherical, and rectangular to cylindrical. What we need to talk about now is how we do double integrals using transformation.